Welcome to the Deep Dive. Our mission today, well, it's to cut through the noise and really understand what feels like the biggest foundational shift happening in software right now. We're talking about how we build and deploy working systems inside conversational interfaces. This isn't just about slightly smarter chatbots. It's really about treating the conversation itself as the operating system. You've probably seen this already, maybe without even realizing the tech behind it. That moment, when a full interactive card just slides right into your chat window. It's not a link you have to click. It's not just a big wall of text. It's like a functioning piece of software you can use immediately. That jump from just typing a request to having a working view, that's what's powered by the ChatGPT Apps SDK.
Exactly. Yeah, it fundamentally changes what doing work means inside a chat. For anyone building software, honestly, this tech is probably the fastest route from just, say, a sketch on a napkin to a real shippable application. And it lives exactly where your users already are spending their time. So today, yeah, we're going to dive into the architecture. We'll start with the two main pillars: the ChatGPT Apps SDK itself, and then the communication standard underneath it all, the Model Context Protocol, or MCP. The goal here is to give you a solid mental model and, a practical roadmap for actually building with this stuff.
Okay, so unpacking the architecture, looking at how it handles application state that seems crucial, and then getting really practical. You mentioned deconstructing a live demo, one that controlled actual hardware.
That's right. A really powerful example of orchestration. We'll get into that.
Okay, so let's tackle the elephant in the room, maybe the immediate history lesson. Anyone who's been in this space for a bit, their first reaction might be, hang on, didn't we already do this with plugins?
Yeah, that's the natural question.
And yeah, we did have plugins. But the sources we've looked at, they're really clear that the difference here is, well, it's profound functionally. Plugins were mostly just text in, text out, right?
Yeah.
Pretty stateless.
Exactly that limitation. That's precisely what the Apps SDK is designed to overcome. It brings, really, two massive architectural upgrades that just change the game for user interaction and chat. First, and this is maybe the most visible change, you get a real UA, rendered right there, inside the chat window itself. Your app can display its interface using totally standard web technologies: HTML, CSS, JavaScript, things developers already know. So think about what that lets you do. Users could scrub through a video timeline, maybe adjust filters on an image directly, confirm a complicated order, fill out a form, all without ever leaving that conversation thread. That immediate visual feedback loop, it dramatically cuts down on context hopping.
Oh, definitely. I think we've all been there, right? You ask the model something, it spits out a link, you click the link, maybe you have to log in again over there. By the time you're on tab number 3, you've kind of forgotten what the original point was. Reducing that friction, that seems huge for usability.
It really is. It's the difference between using an external tool versus having a component that feels native to the operating system, so to speak. And the second big upgrade is the open foundation provided by MCP, the Model Context Protocol. Now, this layer is absolutely critical. It's an open standard connecting the assistant, like ChatGPT, to your external data and your tools. But here's the key architectural difference from plugins. MCP enforces communication through strict JSON schema validation.
Right, that reliance on structure, that sounds like a big deal.
It is. Because it means the language model isn't just generating, some natural language text that you hope your backend system can somehow parse correctly. Instead, it's executing very precise executable functions that you've defined with that schema. Your app speaks MCP, providing that standard contract, but the actual backend implementation, that stays completely yours. You build it how you need to. This commitment to structured function call-driven communication is what really lifts this way beyond the old plugin model. So yeah, the system treats the conversation as the operating system, the UI is a proper first-class view within it, and MCP acts as the standardized bus-moving structured intent and, crucially, state back and forth.
Okay, so the architecture itself, the sources describe it as, well, surprisingly elegant once you see it in layers. They use this great analogy, the brain in the face. It really helps create a clear mental model for anyone trying to build this.
Yeah, it's a helpful way to think about it. Let's start with the brain. That's your server-side piece. The brain is essentially your MCP server. It's just a standard web service. You could build it in Python, TypeScript, Go, whatever you're comfortable with. Its main job is to implement that MCP interface. So handling authentication, talking to your databases or your internal APIs, and then exposing a set of named tools. And these tools absolutely must have detailed JSON schema inputs. That's how the model knows precisely what parameters it needs to send for each specific action.
Okay, so the model figures out the user's intent, calls the right tool in your server, and the server does the actual work, the business logic. But you mentioned something about the outputs being really different, especially for statefulness. What comes back from the server?
Precisely. This is where it gets really interesting compared to older systems. Every tool call returns three key pieces of information, and one of them is, well, kind of the secret sauce for making these conversational apps feel stateful. So first, you get structured content. This is the raw data your UI component, the face, needs to render itself, just pure data. Then you get content. This is optional. It's text the model can read out or display to the user, maybe explaining what just happened or providing context. And then the crucial one, .meta. This is probably the single most important innovation here for building complex applications. Think of Meta as your private, opaque channel. It's a mechanism specifically designed to hold the running state of your application. Things like internal database IDs, maybe large data structures, session tokens, other sensitive details that you absolutely do not want the model to see or reason about. Because the model can't access or interpret what's in Meta, you can safely pass this state back and forth between your UI component and your server across multiple turns in the conversation. That's what enables true, stateful, multi-step interactions.
Oh, okay, that makes sense. That's how you can handle something complex, like configuring a whole dashboard piece by piece, or maybe stepping through a multi-part checkout process, right? Because the state is preserved turn in that hidden meta field. But hang on, if we're rendering arbitrary HTML, CSS, JavaScript, the face inside what looks like a trusted chat window, what about security? How's that vetted? With text APIs, things felt more isolated.
That's a really critical question, yeah. Understandably a concern for builders. So ChatGPT itself handles the surrounding Chrome, the security sandbox around your component, general accessibility features, putting it all together. Your component, the face, actually renders inside a secure iframe-like environment. It receives the structured content data, but it's sandboxed. The real trust boundary is enforced back at your MCP server, the brain. Your server validates incoming requests against the schema, handles authentication, makes sure the model is only asking for actions defined in those tools you exposed. So the security burden really shifts to rigorously validating the structured requests that hit your MCP server's endpoints. And this split architecture, brain and face, it also makes testing much cleaner. You can test your MCP server responses the brain completely separately. Use the developer tools, check the JSON, make sure it's right. Then you test your front-end component, the face, independently. Does it render correctly when given that test data? And only then do you plug it all together in the live chat environment. Much more manageable.
Okay, so the setup seems straightforward enough. You need the right account, something like ngrok for secure local development, Scaffold the server. It's documented. But let's get to that demo you mentioned, where the theory really hits the road. The camera and lights demo, that sounds like it really showcased the potential. Controlling actual physical hardware from chat. That's not a trivial thing.
No, it wasn't trivial, and that's why it was so compelling. It demonstrated modern software orchestration beautifully. It achieved that complexity not by building some giant monolith, but by chaining together small, composable, single-purpose services, exactly the kind of architecture enterprises aim for. Let's break down how they actually did it, and maybe we can generalize the hardware names a bit so you can imagine mapping this to your own internal systems, like databases or dashboards. So first step, they created a dedicated UI for the control panel, just a simple joystick and zoom interface for, let's call it, the video system. Interestingly, they apparently used a coding agent to generate a lot of that UI code just from a sketch, which is pretty cool in itself. But crucially, they built an MCP server dedicated only to that video control domain. Nothing else. That server exposed specific tools like, say, move camera and set zoom. Very focused.
And they didn't try to jam controls for everything, like the lights, too, into that same server.
Yeah, exactly right. They demonstrated the power of keeping domains separate. There was a second, totally separate MCP service just for the lighting system, and it offered its own distinct set of tools like Set Scene or Activate Spotlight, again, very specific to its domain. And each tool, no matter which service it belonged to, returned that structured content we talked about, clearly indicating its new state, the current lighting scene name, the camera's position, whatever was relevant.
That really does sound like microservices, but applied directly to a conversational context. Smart. And what was the final piece? Bridging that gap between these sort of raw hardware commands and just talking naturally.
That was the voice integration. They connected OpenAI's real-time voice API. That allowed them to translate really nuanced natural language requests, things like, okay, pan left just a little bit, or zoom in slowly on that, maybe even set the lights for celebration mode. The voice API translated those into the precise, validated tool calls hitting the right MCP server using the schemas they defined.
Wow, okay, that seamless stitching together of different parts, different services, all triggered by voice. That's how you avoid that context switching nightmare we talked about. Ending up with 7 browser tabs open, trying to remember step 3 of what you're originally trying to do.
Precisely. And they really focused on what the source called context bridges to make it feel smooth. For instance, if the custom UI component was showing the live feed from the video system, it could send a small, non-sensitive piece of context back to the model via that meta channel, maybe something like, user is currently viewing camera feed ID 42. And just that little structured clue makes it possible for the user to ask something like, hey, what am I looking at right now? And the model can answer intelligently because the UI component told it what was on screen. It doesn't have to guess. The whole thing feels almost like magic, but it's really just these small structured interactions enabled by the SDK, stitching the experience together into a reliable conversational workspace. Right, so moving beyond a cool demo to something you'd actually ship, a production-ready app that requires sticking to some clear best practices. The sources highlight 3 main areas: discovery, safety, and performance. For discovery, you've got to remember how users actually find and launch these apps. Either they call it directly by name or the assistant suggests it based on what they're talking about. What that means for you, the builder, is you have to treat your tool metadata, the names of your tools, the descriptions, the parameter documentation, almost like a search product. You need crisp verbs, clear explanations. The assistant has to be able to instantly and accurately match the user's need to your specific tool. No ambiguity allowed, really.
That makes sense. Poor discovery means a great tool might never get used. And this seems to loop back to the importance of that private channel meta, particularly for privacy and safety.
Absolutely critical. Use Meta, always. Consider it a mandatory architectural guardrail, honestly. The Model Context Protocol explicitly gives you this way to keep sensitive stuff, personally identifiable information, internal system IDs, infrastructure details completely hidden from the model itself. If you accidentally expose important state or internal IDs in the regular structured content payload, the model might try to reason about it, or worse, leak it. That leads to model drift, unpredictable behavior, and potential security holes. So Meta is your safe zone for anything the model shouldn't see. And lastly, observability. You just can't fly blind in production. You absolutely must monitor things like tool latency, how long does your server take to respond, what are the error rates, and critically keep an eye on the size of those structured payloads you're sending back. There was a great quote in Material: if a car feels heavy, it is. If your UI component takes ages to load because the data payload is huge, users will just give up. Keep things lean, keep performance crisp.
That point about payload size and latency feels really important. Perceived speed is user experience, isn't it? So boiling it down for someone building their first app, what are the key patterns that work, and maybe more importantly, the pitfalls to avoid?
Okay, what works based on early experience? Design your cards, your UI components to do one clear job. Focus. Answer one specific question or complete one single well-defined action. Don't try to cram too much in. Use small, meaningful, structured payloads. Keep the data clean. Be consistent with your tool names. Use descriptive verbs. Get status, update record, create them, make it obvious, and always return explicit, machine-readable outcomes. Things the model can actually understand and maybe use in the next turn, like status codes, confirmation IDs, things like that.
Okay, clear job, small payloads, consistent verbs, explicit outcomes,
Got it.
and the pitfalls. What should people definitely not do?
Right, the big ones to avoid. Don't treat the UI component like it's just a iframe showing your existing website. It's not a landing page. You need to strip out all the usual website navigation, Chrome, headers, footers, extraneous links. It needs to feel integrated into the chat. Second, don't overload the card visually. No nested scroll bars, please. No super dense tables that are impossible to read on mobile. If you need that level of complexity, design for the dedicated full screen view the SDK offers. And maybe the most subtle but important one: if you find yourself constantly tweaking your prompt, adding lots of instructions, trying to force the model to call your tool correctly, stop. That's a sign your tool contract is wrong. Go back and fix the JSON schema. Make the parameters clearer. Maybe add stricter enums. Let the structure enforce correctness. Don't rely on prompt engineering hacks. #tag outro. I think the core idea, the philosophical shift here, is realizing that users generally ask for outcomes. They don't think in terms of API endpoints or function calls. They want to book a flight or see my latest invoice or turn on the lights. The Apps SDK, built on top of the Model Context Protocol, lets you connect those natural language requests directly to verifiable, executable code that achieves the outcome. By meeting users right where they are already thinking, which is increasingly in conversation, and then returning structured state that the model can actually understand, explain, and help refine. The end result is genuinely software that listens.
It really does feel like this architecture gives us a kind of superpowered conversational interface, almost like a modern command line, but one that understands natural language and can display rich graphical widgets alongside the text. The path for building these kinds of on-ramp applications seems much clearer now. You sketch a UI, you build focused MCP servers for your different domains or tasks, you define structured tools, maybe you wire up voice, and it can all happen within that same conversational thread where the user's initial request or plan started. So the challenge, the one passed on from the source material to you, the listener, is pretty direct. Try taking that camera and lights demo concept and recreating the orchestration part in your own world. Give yourself maybe a week. Swap the camera system for, say, an internal metrics dashboard. Replace the stage lights with controls for switching a customer's billing plan. Then wire up voice control for the top 3 actions people are constantly asking your support team or your tool to do anyway. See if you can make it work.
Yeah, and I suspect the best apps built on this won't necessarily be the most complex ones initially. They'll be the ones that deeply respect the user's time, that are honest about what they're doing via clear UI updates, and that make progress towards the user's goal really obvious. Because, end of the day, this looks like the fastest, most direct way to put real working software in front of the next 100 users who ask for it.
A powerful thought to end on. Thanks for breaking that down. We'll catch you on the next deep dive.